Okay, this is going to be along the lines of similarity. However, it's going to involve a lot of vocabulary from last chapter when we talked about medians, altitudes, bisectors, and triangles. So you really have to keep up on your vocabulary. Okay, so the first thing with similarity is that if we know that two triangles are similar, the lengths of their corresponding altitudes are going to be proportional to the lengths of the corresponding sides. So if you remember, an altitude connects a vertex to the opposite side of a triangle at a right angle. So we can say that side AB over FG equals the ratio of the corresponding altitudes, AD over FJ. And we could also say that equals AC over FH, and that also equals CB over HG. So for the first example, are the triangles similar? Well, remember, we have similar triangles by the following reasons: angle, 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 side, angle, and side, 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 similarity, and side, angle, side, similarity. Oops, actually that one's not one of them. So the reason that these two triangles are similar, triangle KML is similar to triangle XYZ, is because we have an angle and another set of angles congruent in both triangles. So yes, the triangles are similar by angle, angle. Now, because we know the triangles are similar, if you go back up here, remember we said that if the two triangles are similar, the lengths of their corresponding altitudes are proportional to the lengths of the corresponding sides. Well, each of these triangles has an altitude. Remember, an altitude starts at a vertex to the opposite side at a right angle. Vertex to the opposite side at a right angle. So we know that their altitudes are proportional. So let's go ahead and set up an altitude proportion. 16 over this one's altitude, x, should be equal to the lengths of the corresponding sides. So 20 corresponds with 15. So we can cross multiply to find x. 16 times 15 is 240, and that equals the cross multiplication of 20 times x, or 20x. And we'll divide both sides by 20. So we get x equals 240 divided by 20, which is 12. Okay, the next theorem says that if two triangles are similar, then the lengths of their corresponding, well, what's happening here? This angle has been bisected, and this angle has been bisected. And what bisects it is called an angle bisector. So the lengths of the corresponding angle bisectors are proportional to the lengths of corresponding sides. So if these two triangles are similar, which it tells us they are, then LM, that's just one side of the triangle, over its corresponding side RS, and we know that they correspond because LM is the last two letters, and so is RS. Those sides are proportional to the angle bisectors. So we used LM first in the little triangle. The angle bisector of that triangle is LP, and the angle bisector of the second triangle is RT. We could also go one step further and keep going on with this proportion and say that LK, first two letters, is ratio is proportionate to QR, or RQ. And we can set up another ratio for the last set of sides and say KM over QS. Okay, so in the next example it says that the triangles are similar. So in order to find the value of x, we're going to set up a proportion. Well, they each have an angle bisector in the triangle. So we know that the ratio of the angle bisectors x to 8 is equal to the ratio of the corresponding sides, 15 to 12. So once again, we're going to cross multiply to find x, and we have 12 times x equals 8 times 15, which is 120. Divide both sides by 12, and we get x equal to 10. Okay, remember what this is called. We have a vertex to an opposite side at the opposite side's midpoint. Vertex to the opposite side at the opposite side's midpoint. Remember, those are called medians. If you have two similar triangles, then their corresponding medians are going to be proportional to the corresponding sides. So right here we're told that these two triangles are similar. So we can say that AB over WX, first two letters, is going to be proportionate to the medians, DC over ZY. And you can go one step further and compare all of the corresponding sides and their ratios. And we could say AC over WY, or even BC over XY. So in example 3 it says, are the triangles similar? And we can see that there's angle S congruent to angle V, and angle T, I know it's hard to see, but there is an arc here and there's an arc here, congruent to angle W. So yes, these two triangles, RST, is similar to UVW because of the angle-angle similarity. Now, because we've proven that these two triangles are similar by angle-angle similarity, we can say that their medians, because they have a vertex to an opposite side at the opposite side's midpoint, vertex to the opposite side at the opposite side's midpoint, the medians are going to be proportionate to the corresponding sides. So we can say that TP 13.5 over the other median 9 is equal to, well, remember, the sides are the sides of the triangle. So side SR, which is a total of x plus x, so 2x, is going to be over side UV, 3 plus 3, which is 6. And the reason we did that is because, look, this triangle here, the whole triangle, is similar to this whole triangle. So I can't use just part of the side and part of the side of the triangle. I have to use the whole side of the triangle. And since those parts were marked congruent, x here had to be the same as x here, and x plus x is a total of 2x. And 3 is congruent to this here, so this is 3, has a total length of 6. So remember, we have to use the corresponding sides of the triangle, not just portions of the triangle that are given to us. So in solving for x, we do 9 times 2x, which is 18x, equals 13.5 times 6, which is 81. And I would divide both sides by 18. And I would get x is 4.5. And finally, if you have an angle bisector in one triangle, that angle bisector is actually going to divide these two triangles into proportionate segments. So if JM is the angle bisector of triangle JKL, then we can say KM over LM equals JK over JL. This time we don't have two angle bisectors to compare, we only have one. So you're left with the remaining sides being proportionate. So let's explore that further in example 4. We have an angle bisector in a triangle. That angle bisector is going to divide these two triangles and their corresponding parts to be proportionate. So we can say that x over its corresponding side, 13, is equal to 4 over its corresponding side, 6. So once again, we could think of the angle bisector as the division line. X over 13 equals 4 over 6. So the angle bisector shows us what the proportion is. Now we just solve for x. 4 times 13 is 52, and that's going to equal 6 times x. I'm just cross multiplying, and I'm going to divide both sides by 6. And 52 divided by 6 is actually going to give us a decimal, but that's okay. It's going to give us 8.666666667 repeating, so we'll just call that 8.7 is equal to x. Okay, I want you to try number 5 on your own. Pause the video and let's see if you get what I get. Okay, and you should have gotten x is 11.2. This one was a little bit tricky because remember we said you had to do the corresponding parts 11 over its corresponding part 14, and that would equal this segment right here, which we don't know what it is, over x. Well, this segment right here, okay, you should have gotten x is 11.2. Now this one was a little bit tricky because remember we said we wanted the corresponding parts. 11 over 14, remember this is our fraction line, equals this portion over x. Well, this question mark portion is going to be 20 minus x. Let me explain. Think about if we were given a whole segment with a length of 20. It's cut into 2 parts. We don't know what those parts are. We know this one part is 10 though. So then what's left over here is going to be 20 minus 10 because 10's already taken. But in this example, we don't know that it's 10. It's called x. But the same principle applies. Whatever's left over is going to be 20 minus what's taken already, x. So this portion here is 20 minus x. So that's what goes on the numerator. 20 minus x. Now remember, when you're cross multiplying, to put that 20 minus x in parentheses. It reminds us to distribute. 14 times 20 minus x equals 11 times x. 14 times 20 is going to be 280 minus 14 times x, which is just 14x, and that equals 11x. I'm going to add 14x to both sides. So I get, coming over here, 280 equals 25x, and divide both sides by 25. I get x is 11.2. Okay, number 6, this is a median, so this is going to be a little bit different than what we just did. This is like examples that we did before. I want you to pause the video for number 6 and see if you get what I get. Okay, and you should have gotten that x is 8. If you didn't get that, and you're not sure how to get it, raise your hand or ask a neighbor. Okay, number 7, pause the video and see if you get what I get. And you should have gotten that x is equal to 12. If you didn't get that and you're not sure how to do so, raise your hand or ask your neighbor. All right, go ahead and get started on your practice worksheet.